Welcome to a deep dive where we explore the incredible complexity and surprising realities of some of the most iconic aircraft in the sky, all tailored specifically for you. Today, we're looking at strategic bombers, pulling from your sources to focus on two giants of the U.S. Air Force fleet, the venerable B-52 Stratofortress and the mysterious B-2 Spirit stealth bomber. We'll also touch on the surprising B-1 Lancer.
Sounds great.
Our mission is to extract the most important nuggets of knowledge from the articles, research, and discussions you've shared. We want to get a handle on their capabilities, their costs, the challenges, and their ever-evolving role in modern warfare. Think of this as your shortcut to being well-informed on these aerial titans.
Yeah, it's a fascinating look, isn't it? How aircraft designed decades apart are, serving alongside each other. They're facing massive modernization hurdles and sparking real debate about their place in future conflicts. It really highlights that intersection of technology, cost, and strategy.
Okay, let's unpack this, starting with the absolute legend, the B-52 Stratofortress. I mean, this plane has been a cornerstone of the U.S. Air Force since the 1950s. A long time.
It's absolutely earned that status.
Mm-hmm.
Just through sheer endurance and capability, known for its incredibly long range, meaning it can fly immense distances without refueling and carrying a truly massive payload. Just an enormous amount of ordnance or missiles.
And its history is incredible. Your sources highlight its critical role back in the Vietnam War.
Right.
Flying over 126,000 sorties in operations like Arclight and Linebacker 2.
Huge numbers.
Then you fast forward decades to Operation Desert Storm, and it was still delivering a significant chunk of the coalition's air ordnance.
Yeah, that kind of sustained effectiveness over, half a century?
Right.
It's really rare. And what's fascinating here is its adaptability. I mean, it was designed during the Cold War primarily for nuclear deterrence.
Right, the strategic mission.
Yeah, exactly. But it's proven incredibly versatile in modern conventional conflicts. It can carry both nuclear and conventional payloads, obviously, but today, that often means launching up to 20 air-launched cruise missiles from a long distance. That standoff attack capability.
Which keeps the bomber itself out of immediate danger.
Precisely. Standoff capability is crucial in, contested airspace.
And despite its age, it's adapted to carry precision-guided munitions like JDAMs and laser-guided bombs, making it surprisingly accurate.
Which is amazing for an airframe that old.
Yeah. It's used for everything from strategic strikes to hitting targets closer to the front lines, even maritime operations. It's become a kind of multi-tool in the sky.
A flying truck? Almost, but a very capable one. Technically, it still retains its 8 engines.
Still 8, even with the upgrades.
Yep. Even the new F-130 re-engine program, which will give it the B-52J designation, keeps all 8. Sources note it has a relatively small rudder, but apparently asymmetric thrust from an engine loss is surprisingly manageable.
And here's a cool detail from your sources. The main landing gear can pivot up to 20 degrees.
Ah, yes, for crosswind landings. It makes handling such a huge plane on the ground a bit easier, supposedly.
But the operational reality, as your sources really underscore, is that these are old planes.
Very old.
Crews often have to balance the essential training they need with the reality of non-critical equipment being broken.
Right, things like targeting pods or maybe a radar altimeter not working perfectly.
So they're making tough aircrew decisions about what they can actually fly with.
Exactly. Because, as one source put it, the mission still has to get done. You have crews pushing these, 70-year-old airframes while dealing with issues that might ground a newer plane simply because the operational need is there.
Which brings us neatly to the massive effort to modernize these aging birds, specifically the Commercial Engine Replacement Program, or C, or...
And the Radar Modernization Program, RMP.
Right, and your sources paint a picture of pretty significant challenges here.
They really do. The B-52's age isn't just about wear and tear, bringing it into the 21st century. Technologically and, bureaucratically, has been a battle of its own.
Yeah.
Take the engine replacement with the CRPR. It hit a major speed bump.
Okay.
The program had to switch from a faster, simpler approval track, a middle tier of acquisition pathway, to a much more complex, traditional regulatory process, a major capability acquisition.
Okay, so moving from a quick permit process to something more like getting approval to build a skyscraper. Is that a fair analogy?
That's a pretty good analogy, yeah.
Yeah.
That switch consolidated a lot of work. And critically, one source noted, created the opportunity for the prime contractor to raise costs. Add in delays from things like a revised engine inlet design, and you see how that complexity just builds and builds.
And the radar upgrade, the RMP, faced its own drama.
Oh, yes. The RMP, which integrates a new Raytheon radar, had a major breach in its schedule before it even reached the point where they decided to start production.
Before Milestone C.
Exactly, before Milestone C. The initial cost estimate back in 2021 was around $2.3 billion, but now it's estimated at $3.3 billion.
Wow, $1 billion jump in schedule delays before they even really started making them.
Yeah.
What does that tell us about trying to integrate complex new systems into these legacy airframes?
Well, it tells us it's incredibly difficult and expensive. It really highlights the immense risk and cost involved in trying to make a 1950s airframe compatible with, 21st century digital systems.
So what are they doing about it?
The Air Force is trying to claw back both schedule and cost. They're reassessing requirements for the engines, asking if everything on the wish list is truly essential. For the radar, they're doing things like using undefinitized contract actions.
Which sounds risky.
It basically means signing contracts to buy long-lead parts before the final price is fully negotiated. They're trying to accelerate things, but yeah, it carries its own risks.
Trying to buy components faster because supply chain issues are also a problem, right? I saw that mentioned.
Absolutely, a huge problem. Long lead parts for the radar production were initially thought to take maybe 18 months.
Oh, okay.
But the estimate is now around 30 months.
Oof.
The Air Force is apparently asking Boeing, the prime contractor, to pressure Raytheon, the supplier, to speed things up. It's a whole tangle of contractors, subcontractors, and supply lines.
And there have been changes in management to try and get these programs back on track?
Yes, Boeing brought on a new, apparently seasoned program manager overseeing both the engine and radar programs.
Ew.
And notably, Shay Assad, who's known for his work on contracting efficiency, has been brought in to help with pricing and proposals on both the government and Boeing sides.
So it wasn't just Boeing's issue?
No. One source was careful to point out that issues existed on the government side as well.
Yeah.
It's a complex ecosystem, as they put it.
So while these old planes are out there flying missions and getting these upgrades, that whole process itself is a huge, costly, and complicated undertaking.
It really is. And, you see these planes visible to the public sometimes, like in those recent sightings of a B-52 and a B-1 flying over central Stockholm.
Right, with the Swedish Jaws Gripen fighters.
Yeah, likely linked to Sweden's NATO entry and exercises.
That must have been something to see. Your sources mentioned the public reaction, people noticing their immense size.
Definitely.
And with the B-52, that visible engine smoke often comes up, described as smelly, produces nasty soot exhaust, smoky like crazy.
Yeah, that's a common observation. Though, the new engines are supposed to change that significantly.
Cleaner and more efficient, right?
Yes, the F-130s are much more fuel efficient and cleaner burning. People also notice how the B-52's wings droop so much on the ground, something like 22 feet from the tips.
Wow.
And that you can actually walk up and touch a wingtip on a parked one. It just drives the sheer scale of these aircraft.
Okay, so from that enduring, very visible giant, let's pivot to the other end of the spectrum. The stealth mystery, the B-2 Spirit.
The B-2, developed by Northrop Grumman, a multi-role heavy bomber designed from the ground up for one primary purpose: undetected penetration of sophisticated enemy defenses.
And its origins are just legendary for their secrecy, aren't they?
Absolutely. Your sources describe it as a black project during development, less known initially than maybe the F-117 stealth fighter, but still highly classified. Working on it required special clearances, extensive background checks.
They even used a former Ford plant in Pico Rivera for assembly.
That's right, masked with intense security front companies, polygraphs for employees, officials visiting out of uniform, the whole 9 yards. Nearly all information was kept from even the GAO and Congress until the mid-1980s. It wasn't publicly revealed until 1988, and its first flight was in '89.
That level of secrecy added to its mystique, but it came with a massive price tag.
And that's really the headline for the B-2, isn't it? The cost?
It seems like it.
Absolutely astronomical. Your sources put the estimated operating cost at roughly $169,000 per hour.
Per hour?
Per hour. And the total program cost, including everything from development to decades of operation, maintenance, upgrades, could easily exceed $100 billion over its lifespan.
Just staggering.
The initial cost per plane was reportedly around $2.4 billion. And that specialized maintenance needed just to keep it stealthy is a major contributor to those high operating costs.
Okay, let's delve into that stealth technology. It's not just about dodging radar, is it?
Correct. It's a multispectral approach. reducing signatures across acoustic, infrared, visual, and, of course, radar. It's about being as invisible as possible across the board.
For radar, that flying wing shape is inherently beneficial, I assume.
Hugely beneficial. The reported radar cross-section, or RCS, basically how big it looks to radar, is tiny. About 0.1 square meters is the figure often cited.
Like a large bird, almost.
Something like that. And a key part of that radar stealth is what they call continuous curvature across its surfaces. This was a huge technological leap enabled by computing power in the 1980s, unlike the earlier, more angular, faceted design of the F-117. It deflects radar beams away.
And no tail fins.
Crucially, no vertical tail fins, which are notorious for showing up on radar. Sources also suggest it's less vulnerable to some lower-frequency radars compared to aircraft with those big vertical surfaces.
So does it always fly in full stealth mode, then?
No. Sources mention pilots have procedures to stealth up, as they say, when they approach areas with air defenses, and opening the bomb bay doors does briefly increase its radar signature. Understandably.
Okay, what about infrared signature? How do you hide the heat from those powerful engines? That seems incredibly difficult.
It is one of the most complex parts. The engines are buried deep inside the wing structure, which helps. But to minimize the heat signature further, they do something clever. They mix cold air pulled from the boundary layer under the wing with a hot engine exhaust before it exits the aircraft.
Okay, so pre-cooling the exhaust.
Essentially, yeah. It cools the exhaust significantly. That still warm air is then dispersed over heat-resistant carbon fiber and titanium surfaces to cool it down even further before it dissipates. And crucially, it lacks afterburners.
Right, which would be like a giant heat flare.
Exactly. An enormous thermal bloom.
That is fascinating. Essentially cooling and spreading the heat out to make it blend in. What about visually? How do you hide something that big in the sky?
Well, it uses anti-reflective paint to reduce glare in daylight. The undersides are painted dark to help it blend in against the sky at high altitude. There's even speculation about a sensor that measures the sky's light to help the pilots adjust altitude to match it, though that's less confirmed.
And contrails.
It has a contrail sensor that warns the crew if they're leaving visible streaks behind them so they can change altitude. But it's not truly invisible up close. Sources say it remains vulnerable to visual interception within about 20 nautical miles or so.
Keeping all that stealth technology operational sounds like a maintenance nightmare. You mentioned the cost.
It absolutely is a major challenge and a huge cost driver. Or sources detail the requirements. Specialized climate-controlled hangars are needed just to protect the radar-absorbent materials and coatings.
Costing millions each.
Reportedly $5 million each, yes. The coating itself needs incredible care every 7 years. It's apparently washed away with crystallized wheat starch for inspection.
Wheat starch? Seriously?
That's what the source says. It was also built with unusually tight engineering tolerances to avoid leaks that could compromise the stealth. They've developed innovations over the years, like alternate high-frequency materials and automated application methods to try and make the coatings more durable and easier to apply. But it's a constant, painstaking effort.
Inside the cockpit, how does the crew manage such a complex aircraft? It's just 2 people, right?
Crew of 2, a pilot and a mission commander, though provisions exist for a third. Compare that to the B-1's 4 crew or the B-52's 5.
So it must rely heavily on automation.
Hugely. Sources say one crew member can actually rest, use facilities, or get food while the other monitors the flight and mission.
Which it needs, I imagine, with a flying wing design that's inherently unstable.
Precisely. It requires an incredibly complex, quadruplex, computer-controlled, fly-by-wire system just to maintain stability. It doesn't even use traditional pitot tubes for airspeed and angle of attack.
Why not?
Self. Traditional tubes stick out. It uses sensing plates instead, which means the computers have to interpret that data very carefully. Flight controls are hydraulic and electrical with multiple layers of redundancy. Directional control relies on split brake rudders on the trailing edge of the wing and differential thrusts from the engines. Very sophisticated.
The avionics system also sounds like a beast.
Originally controlled by 13 separate EMP-resistant computers, they're apparently consolidating many of those into a single integrated system now. They're all linked by buses and optical fiber for redundancy and speed, state-of-the-art for its time, and constantly being updated.
Given that intense secrecy and advanced technology, it's maybe not surprising, but still unfortunate that there were instances of espionage.
Yes, tragically. Your sources mention Thomas Patrick Cavanaugh, arrested way back in 1984 for attempting to sell information to the Soviet Union, and Noshir Gawadia in 2005 for selling information related to its propulsion and stealth to China. It just underscores the value placed on that technology by adversaries.
The B-2 has also had a few notable accidents over the years, which must be incredibly costly given the price per plane.
Sadly, yes, and they really highlight the complexity of the aircraft. The 2008 crash in Guam.
That was the Spirit of Kansas.
That's the one. A $1.4 billion hull loss. It was caused by moisture getting into sensors that measure air data during calibration. This distorted the information, leading the computers to calculate an inaccurate airspeed and angle of attack, causing the plane to pitch up violently on takeoff.
Wow.
It revealed problems with how critical information was communicated and maybe the crew's full understanding of these incredibly complex systems.
Led to a fleet grounding.
Yes, the whole fleet was grounded for a while afterwards, and they added pitot heat to the calibration process to prevent it happening again.
There was also a landing mishap more recently.
Yes, in 2021, the Spirit of Georgia went off the runway at Whiteman Air Force Base. That incident was linked to faulty landing gear springs and something called micro-cracking in hydraulic connections.
Expensive damage.
Over $10 million in damages reported for that one.
And another emergency landing and fire in 2022 led to yet another temporary grounding of the B-2 fleet.
Right, and these accidents, particularly the damage from that 2022 incident, factored into a significant recent decision.
Which was?
The B-2 damage in that last incident will not be repaired. It's been deemed uneconomical.
Uneconomical for a B-2.
2. Your sources note that this decision was very likely influenced by the imminent arrival of the B-21 Raider. In the past, losing a penetrating bomber was such a strategic concern that damaged B-2s took years and over $100 million to repair. They absolutely wanted them back. But with the B-21 coming online soon and the B-2 fleet slated for retirement after 2029 anyway, repairing that specific aircraft just wasn't seen as worth the massive expense anymore.
That makes sense. It's also notable that no operational B-2s have ever been put on display in a museum, right? Only a test article.
Correct. They're still considered too sensitive or perhaps just too operationally critical to be retired to a static display yet.
Okay, we've delved into the long-serving B-52 and the complex, stealthy B-2. Let's quickly touch on the surprising beast, as your outline calls it, the B-1 Lancer, often seen flying alongside the B-52.
The Bone, as it's nicknamed.
Well,
Yeah, when people see it next to a B-52, they're often astonished by its size. Well, the B-52 actually has a slightly larger wingspan and length. The B-1 just looks incredibly substantial, very sleek and powerful.
people comment they had no idea it was that big.
Exactly. And yes, you apparently can walk completely under it. It's a large aircraft.
Despite that visual perception, sources note it theoretically has a larger payload capacity than the B-52.
And the practical difference is even bigger, apparently carrying around 7,000 pounds more payload. And crucially, it carries more of its ordnance inside its bomb bays, which is better for aerodynamics.
Performance-wise, it's a completely different animal from both the B-52 and the B-2, isn't it?
Oh, completely. It's described as almost fighter jet-like in how it flies compared to the others. It's fast.
A whole nother level was the quote, I think.
Right, compared to the B-52. And it's supersonic capable, which neither the B-52 nor B-2 are. It has that distinctive swing wing design like the old F-14 Tomcat, which reduces drag significantly at high speeds.
And afterburners.
Yep. Unlike the stealthy B-2, it uses powerful afterburning turbofan engines, which contributes massively to its speed, but, of course, creates a large heat signature. Stealth wasn't the primary driver for the B-1B.
One comment in your sources even claimed it holds the record for the fastest circumnavigation.
That specific record might be debated depending on the exact criteria used, but it certainly points to the B-1's impressive speed and range performance. It's a fast plane for its size.
And operationally, it's been extremely effective in recent conflicts.
Hugely effective. During the first 6 months of Operation Enduring Freedom after 9/11, just 8 B-1s dropped nearly 40% of the total coalition bombs.
40% from just 8 planes.
Yeah, including 2/3 of all the precision-guided JDAMs used in that period. Then in Operation Iraqi Freedom, they flew less than 1% of the total combat missions, but delivered 43% of the JDAMs dropped. Incredible efficiency.
And they were used for those low-level thunder runs.
Right. High-speed, low-level passes specifically designed to shock and awe enemy forces. A very different role than the high-altitude B-52 or the stealthy B-2.
A crucial distinction from the B-52 and B-2, though, is that the B-1B fleet was stripped of its nuclear capability, correct?
That's correct. As part of armed control treaties, it's now purely a conventional bomber, a very potent conventional power projection platform.
And like the B-52, the B-1 is seen out there, including that recent Stockholm flyover you mentioned.
Yep. And visitors to air museums who see it parked next to other large bombers like the B-29 Superfortress or the even more immense B-36 Peacemaker are always struck by its sheer physical presence. It holds its own.
Okay, so we have these three incredibly different aircraft spanning decades of design philosophy, all still part of the fleet, all capable of carrying heavy payloads. This brings us to a fundamental question that your sources wrestle with. What is the point of strategic bombers in the modern world?
It's a huge debate and a really important one. First, maybe let's clarify the traditional terms, though they're admittedly blurrier now. Strategic bombing historically meant targeting things like cities or industrial infrastructure deep in enemy territory to force a surrender.
Right, affecting the will to fight.
Exactly. While tactical bombing targeted military assets closer to the battlefield, tanks, troops, bridges, etc. Your sources note that today these bombers we call strategic are very often used for tactical missions, dropping JDAMs on specific targets, for instance.
And that leads some military analysts to question the massive expenditure on them, doesn't it?
It does. The argument goes, why use a multi-billion-dollar bomber when long-range missiles launched from cheaper submarines, ships, ground launchers, or even multi-role fighter jets can perform similar strike tasks, often faster and with less risk to personnel?
It's a valid question.
And this is where U.S. military doctrine really diverges from most allies. Most air forces around the world believe bomber missions can be done by other platforms and have gotten rid of dedicated heavy bomber fleets.
Like the UK and France.
Right. The UK relies on nuclear submarines for its deterrent. France uses subs and carrier-launched fighters for its nuclear roles. The U.S. Air Force is pretty unique in the Western world for maintaining this large, dedicated strategic bomber force.
So what's the U.S. rationale then?
Well, first and foremost, strategic bombers are seen as a critical, flexible leg of the U.S. nuclear deterrent triad. You have the land-based missiles, the submarine-launched missiles, and the bombers. They provide unique signaling and recall capabilities.
Okay, the nuclear role is key. But beyond that?
Beyond nuclear, the argument is they offer unique operational capabilities others can't match. The B-2 specifically is designed to use stealth to penetrate heavily defended airspace and strike targets that other aircraft or even some missiles might struggle to reach undetected. And they can carry truly enormous amounts of conventional ordnance, far more than a single fighter jet, or what you could fit in a missile silo. They offer persistence, too. They can loiter near a target area for hours.
But even the stealthy B-2 isn't without potential vulnerabilities in the most contested environments, is it? Your sources raise that point.
That's the counter-argument, yes. Bombers, even stealthy ones, are generally slower and potentially easier to track than advanced hypersonic missiles. There are definitely questions raised about the B-2's effectiveness against the very latest threats, like advanced infrared search and track systems, IRST, or even sophisticated visual detection in certain scenarios. Some worry they could become dead ducks if acquired by those systems.
So the argument becomes, is the penetration capability still worth the risk and cost?
Exactly. Some analysts argue that the B-2's best use today is actually launching cruise missiles from outside enemy air defenses, acting as a standoff platform. But that's a task that a much cheaper, modernized B-52 could also perform very effectively. So you get into that value proposition debate.
It's a constant reassessment of value versus cost and vulnerability, especially in the face of evolving anti-access, area denial capabilities from potential adversaries.
Precisely. It's a dynamic equation. And the arrival of the next generation bomber, the B-21 Raider.
Which we see influencing decisions already, like the divestment of that damaged B-2.
Right. The B-21 marks the beginning of the next chapter for the strategic bomber fleet, and it will surely reshape these debates even further.
So what does all of this mean for you listening in? We've taken this deep dive into aircraft with incredible legacies, some cutting-edge and incredibly expensive technology, and also the complex, sometimes messy reality of keeping them operational, modernized, and relevant in today's world.
Think about that contrast we saw. The sheer visible power and 70-year history of the B-52 and B-1 operating for decades and undergoing these costly, complex upgrades just to keep flying. Contrast that with the almost invisible, highly complex, and astronomically expensive stealth of the B-2, designed for penetrating defenses but now facing questions about its effectiveness against the newest threats.
Yeah, and the debates about their continued relevance in an age seemingly dominated by missiles versus their unique capacity to deliver massive payloads, sometimes with stealth, or simply project global power just by showing up like that sighting over Stockholm you mentioned. Presence matters.
It does, which raises an important question for you to consider. As military technology continues its rapid evolution and the nature of conflict potentially changes, What is the true strategic value and the ultimate cost, both in dollars and operational complexity of projecting power through the air with crewed bombers? And what is the journey from the B-52 through the B-2 and B-1 to the arriving B-21 Raider tell us about the evolving path of future warfare and the platforms we choose to wage it?